Hi, this video explores my Millwork walls package. I've catted the outline of the wall we're going to create. There's nothing actually there, it's just lines. So we're going to drag our Millwork wall object out of the library and edit its shape. There's nothing really special about this object. There's no object intelligence used in this system. It's all UCS and construction method driven. This object just has a preserved construction method and material schedule. So everywhere we want to put panels, whether they're on the inside or the out, we're going to call a face. Everywhere we touch a wall or another millwork wall, we're going to call a none or an end none, whatever you prefer. If we had an end that was going to be capped with a panel, we could call that a finished end. And this is a none. We'll go ahead and set the height of the object and make sure it's at the floor. This outline does include the panels that we want, so it's the overall size of the object. These little arrows are face control panels. They are how we control what happens on a given face. You'll see we have the word error here. That's because I require each face to be named. There are certain standard names available that can be used to generate automatic drawings of which faces are where, but you can name them any arbitrary value. Any of the parts that go in each face will get this name, so it makes it real easy to put together. And as soon as we have every face named, you'll see the word error disappear. Alright. To begin with, we need to place what I call cleats, which are the members used to fasten through into panels. And all we do is select a face control and tell it how many we want. That's it. With each face control, you'll see we started with basic options, so we could change the width of any given cleat, the altitude from the floor, the inset. We can change to face level value, so we can adjust all the cleats on this face left, etc. We can break them, which as you can see now broke it into parts over here and parts over there, just in case our face exceeds our material length. Or we can get very detailed, and for each and every cleat we can set the width, the altitude, inset, adjust it left, adjust it right, plow it into the stud, which means create a dado into the stud and make the recess for it that's in the stud smaller. We can delete the part but leave all the machining. We can use these to delete just a segment, so we could delete from 12 to 24. And you'll see now we have a chunk cut out. There are other methods we can use to delete as many arbitrary number of segments as we want. But we'll go ahead and hide these because we can't see very well with all those options up. I could go around and tell the next face how many cleats I want, but an easier way is to just tell the next face to follow this one. So I'm going to work my way around and tell each of the outer faces to follow the first one. You can see here it adjusted which cleat was long. So if I set this back, so by default this one runs past, but as soon as I add cleats to this face, this one's smart enough to move out of the way. That is not limited to 90-degree angles. It'll work with any arbitrary angle. With 90-degree angles on outside corners, it will run one past the other, and on inside corners it'll leave a void. With any other angle, it'll leave a void to make sure that it's able to be used. Now the inside is going to have a different set of cleats. So we'll just set it to 3 for now. And then our second cleat up, we're going to want to be 5 inches wide. And we're going to want it to be underneath the countertop height. Alright, making good progress. Next thing we're going to do, we're going to add some panels. So we'll go to the section editor. And we'll add a panel. We'll go ahead, we'll do a toe recess. So we'll bring that panel up 4 inches to allow for a toe. We'll just make that same set of steps all the way around. The inside section is going to be a little different. Generally speaking, we're going to split that into 3 sections. The top of which we're going to call a blank panel because it'll be probably tack or something. The middle of which is just an open. And it's going to be the countertop thickness plus a 16th just for some clearance. And we'll lock that so it can't ever change. The bottom section is going to be the height underneath the counter. And it's also going to be a blank panel, just so we can change what it is. I'll go to one of my ortho views where I can click on that part. We're going to change the bottom part to 3/4 black melamine. And we'll change the top to a tack surface. Okay. You can see in 3D here we got some faces fighting one another for their Z order because they overlap. And so see what Cabinavision's doing here, just overlapping these panels. We don't want that. I have options on each panel to either extend, which just means make it bigger when we go to CNC, or miter. So we're going to miter the right side of this face, and my UCS will in fact automatically add a 1/4 inch of oversize to any panel that's being mitered so that it can be placed back up on a saw and cut to length. It also helps because these walls generally grow a little bit and you don't want to cut your panels exact sized anyway. So if we didn't have mitered faces in here, we would want to go ahead and add some overage. And, oops, I missed this one. I mitered the wrong side. Now I'd said we wanted to have a toe recess. So we're going to go back to this face, which is controlling all the others. And you'll see if I click on one of these, I don't have very much in the way. I don't have a cleat number that I can set. I don't have much in the way of options. I can still override, do face adjustments, and I can override individual cleats. But for the most part, it's simply following what that first face is doing. So we'll come back here. We have this face toe option. We'll set that. Tell it I want maybe a 5-inch tall toe. Which you'll see pushed the cleats up. And since they're all following this one, let me go ahead and hide my panels. Since they're all following this face, it pushed them all up. All the way around, except on the inside, which is exactly what we want. And we will tell it that we want, let's just say 1.5 inch recess, and that we wanted to put a cleat there as the toe. because we just want this unfinished surface that somebody can put some vinyl over the top of. You know what? We made our toe kick 4 inches tall, not 5. And if we set behind the toe, it'll push it back behind as if we were going to put a finished panel over it. You can see as it insets, for the most part, there's a little problem right there I can see, but it does properly downsize. So let's just say we push that in 2 inches. You can see it's downsizing the panels so that it still works out as everything's the correct length. Again, that's not limited to 90-degree angles. It works with any arbitrary angle. Here I can see I have an 1.5 inch space there that I wanted that it didn't calculate, so I can come in. I can show my cleat options. I actually need to show them all. And that cleat number 0 is my toe, so I can adjust the left 1.5 inches. Now it's getting kind of hard to see what all this is. We can put it into filled mode, but that doesn't help too much. A little bit. I have this little color coding option that changes the color of every part. So now it's a lot easier to see, and we're going to unhide our panels. There we go. And we can see down here, we got some conflict here. The one thing I can't auto size right now is making the bottom plates adjust for toe recess. So that is a manual step. We're just going to edit the shape, and we're going to move it back behind our toe all the way around. The bad part about that is A, it's prone to be error, and B, if we adjust the length of this, most things are going to fix themselves. Or if we adjust the shape, most things are going to fix themselves. But the bottom and the double bottom are going to stick to the shape we gave them. So we always have to remember to fix the bottom if we adjust something. Not very difficult though. And we can see in 3D with our color coding whether we're correct or not, and we're correct. We can come around to the inside and let's hide this stuff so we have some more room to work here. Put in some wire chases. Not seeing anything because we haven't put any studs in. So before we see anything, we need to put some studs in. We're going to start from the inside here, but you can place them from whatever face you'd like. We'll split this into 3. Oop, that is not what I meant to do. This is supposed to be a panel, a blank panel even, with a locked height. And we'll come back to that. Let's just hide our panels while we work on these studs. So we're going to section the interior, and we're going to place partitions, which are our stud. On the side up against the wall, I like to have about a 1/2 inch of scribe space. And over here, we're just going to send it all the way to the left. And then we're going to split this up into, say, 7 openings. I don't mind that. I usually aim for 12 to 16 inches between studs. And you can see we're getting, if we explode this, we're getting a notch for each cleat. And we're getting these wire chases cut in, which we'll want to come back and adjust because there's like an 1/8 inch of material there. The intermediate cleats, and then not the top and bottom, are being plowed out and have a screw hole drilled into them. So they'll fit into this notch. And the bottom and top plates are likewise being plowed out and have screw holes. Makes for very easy assembly. Let's put that back together quick. We'll finish studding this out. I'm going to go to this little face. We're going to split it into 3. Over here we need to stay back because we have this toe notch. You can see the toe there. So this space is going to be 1.5 inches. We'll lock that so it can never change. We'll send this guy all the way to the left. And maybe that's a bit large of an opening, so we'll add another stud in there. Okay. And we will pop over to this end. We'll add our 3 partitions. Pretty much the same process here. We need 1.5 inches there because we have our toe notch. And we'll send this to the left. Alright, and that is too far. So we will unsend that to the left. We'll give it a little space there. Still too far. Okay, that's fine. So we're making good progress. We're actually gonna get rid of the wire chases from here because I had set all these faces to copy this outer face, just to save myself the maximum number of things that I have to do. There we go. We will make the top one a circle. And let's just move it up to, say, 34. No, 32 maybe. Let's move this bottom one up. And like everything else, we can adjust any individual one and make it smaller or bigger, but there's some sane defaults. Okay. Let's show our panels again. And then I readjust that inside one. Because I changed it earlier, I lost my white or my black melamine override. We're going to come in here, click on this interface, and we're going to add some removable panel cutouts. Can't always get away with this, but we generally try to simply cut out using a small tool where our panels are going to be, and then that way everything stays grain matched if it's material. It's easy to do. Now you can see what I'm getting now are my 3 12-inch wide equally spaced panels. We could tell it we want to have 3 inches of clearance on the left. We could tell we want to have 6 inches of clearance on the right. And we could tell we want them all to be 16 inches wide. Alternatively, we can tell it we want them all to be equal. And we want our 3 and our 6, and then 6 inches in between. Pretty easy. Have some other cool things, like a drop down. We can adjust the top down in a whole face at a time, which would bring all the studs in there down, and also delete any cleats that were in that space. So see how it deleted the top cleat. This is not an example of that though, so we'll get rid of it. Just to show some examples of other shapes that work, I'm going to pause it while I draw one. We'll We'll go ahead and we'll put some cleats on here. We'll put cleats over here, cleats over here. And you can see it's sized them properly so that they won't conflict with one another. Actually, let's just tell, this is face 2. Let's tell this to follow so that we can modify everything at the same time. If I inset one of these, you'll see their sizes are adjusted so that they still don't conflict. We can also do radiuses and arcs. Again, I'm going to pause it while I draw this. Okay. You see, there's a little bit different on the radius. We've got the same standing board we had before. We also have a strut inside, which allows us to fasten through to this curved standing board. It adds a few more options. For example, we can disable a given strut, or we can change the position of it, change the width of it. Let's move this guy up so we can see what's happening. Studs work same way. You can put them in from either face. And it looks to the opposite faces. Sometimes it fails to detect the other face, so we have to tell it what it is. The opposite face of this is face 6. The opposite face of this is face 2. This only happens with radiuses. Now we'll pull it apart. You see, you end up with a stud with a notch out like this. I didn't mention this before, but all of the stud notches uses a line bore to ensure a perfectly square corner, and all of the parts are sized to fit with a little bit of tolerance inside of where they go. As you can see here, it even adds a line bore for a screw hole into the standing cleat on a radius, which is pretty cool. Everything else basically works the same here, so nothing special there. That is all I have for my video. Thanks.